Hey guys, sorry for the little delay there, but I'm back with another video. This time I'm going to be doing a video about partial fractions and how to integrate them. This can be applied for both Calculus BC, if you're taking that, not really to AB, but it can be also applied to pre-calculus because they might teach you only about making it into partial fractions. If you understand what I mean. If you don't, I'll tell you in just a bit. In Calculus BC, they expect you to know how to do partial fractions, and how to integrate them as well. So partial fractions, just getting it, is just algebra basically. So that's why it's in pre-calculus, and Calculus BC, it involves integrating them, which is pretty simple if you know how to do U substitution and you know a couple of integral rules. Sorry. So without further ado, let's get on with it. So to first learn about integration by partial fractions, you might not know what partial fractions are, so you need to know what they are before you can integrate them. So before we begin, here are some basic fraction addition problems. Just try these and see how you do. Alright, I'm assuming you've given it a go, so I am going to move on. You may pause the video, you may have. So sorry about the weird fonts there. There's a weird font change in some of them. So sorry about that. So while you are adding them, think about the process that you use. You probably did something along the lines of making the denominators the same by multiplying both the top and bottom of the fraction, and then you added the numerators. So you probably did something like this. In this instance right here, I did example A from the previous slide. Here you can see I got 5/4, and if you see I just did basic fractions, making the denominator the same, the denominators the same, and then adding the numerators right after. And you can see I got 5/4 or 1.25 if decimals are needed for some reason. So I'm try this now. We're gonna try it with some variables, yeah. So just try and solve this, and see what you get for A and B. So assuming you've given it a go, I did rename the variables here. So that was an accident by me. A corresponds to C and B corresponds to K. Sorry about that mistake. So just when it says 17x plus that number, just assume it says it is C. And here's my work here. You can see I made the denominators same, and by multiplying it by the other denominator. And then I combined the two numerators to get 17x plus 143 as C, or you may have seen it as A if you're referring to the previous slide. Sorry about that mistake yet again. Just remember the x value when you're doing it. And so what we're doing essentially, when I say partial fractions, I essentially mean expanding it out. So the process that we just did here, partial fractions is essentially the reverse of this. Now you might be thinking, like, how do you find out the denominators? Because if you are just given what's on the right side of this equation, if I just gave you the right side of this equation and told you to expand it, you might not know how to expand it out. So that's what I'm going to show you next. And this is where we're going to start by actually going into partial fractions. So far I've just been showing you some review stuff that you should know before diving into this partial fraction problem. And also, I'm going to be using the same problem, and you can use that to check your work in the upcoming slides. So, if you don't get what I mean, just stay tuned. Here. So, what if we did this in reverse? What if I asked you, expand this following fraction, and you already know the answer because it was just in the previous slide. It's the same example that I gave you earlier. But how would you show the work for it? You know what the answer is, but that's not the point. In the calculus exam, on your teacher's tests, or whatever it is, you're probably going to need to show work. So how do you do this? And keep in mind, I said this before, if you know, since we know the answer to this already, so you can use it to check whether you're correct or not. So we're going to expand this fraction. So first things first, we have to factor out the denominator. Specifically, we can see it's a quadratic function on the bottom. And so let's try doing that here. And here's the expanded version. Probably saw it before. And notice how we didn't do anything to the numerator because the denominator stays the same. I just factored it out. I didn't change really anything. So, do recognize that the factors are the denominators to the expanded fraction will be whatever you had earlier. As in, like, the factors of the denominator that we got from this fraction will be the partial fractions denominator. So you see that our on our previous slide we had the non-factored version. Now that we factored it, we know that we can tell that each of the factors are going to be the denominators, as I showed in this equation right here. 17x plus 143 over x plus 9 times 2x plus 16 is equal to c over x plus 9. By the way, c doesn't correspond to the previous c that I mentioned earlier. It's a different value this time, and same thing with k. And k over 2x plus 16, so that's going to be equal. Those are going to be equal to each other and now we need to find out. Now we need to find c and k. So that's what we're going to do next. And the following steps might be a bit more complicated, and this is really the heart of it, I think, of this topic. So, as I mentioned earlier, you need to solve for c and k, but you have 3 variables in this equation, which means you can't really solve for any one of them unless you cancel some of them out. And there's no obvious way right off the bat that we can cancel any big terms. Try it yourself. If you can't, just keep on watching the video. But either way, so think about what you can do to eliminate just some terms, not necessarily variables. See if you can just eliminate some terms. Find the first step of what we're going to do. Try to guess what I'm going to do next. If you guessed that multiplying the value to multiplying the denominator on the left side of the equation was the correct answer, that is correct. That is what you should do. You should multiply the denominator, as I mentioned right here. Once you are done simplifying, you should have something like stated below. 17x plus 143 is equal to c times 2x plus 16 plus k over 9, because the terms do cancel, because you put the entire quadratic over one of the factors of the quadratic, and so the corresponding factors eliminate on each case. So but you still have 3 variables, so you need to try to solve it. And you can see I wrote it down here already. It's written down, but if you didn't read it yet, basically what it says is plug in a value for x that'll eliminate one of either C or K, because we need to solve C or K. So first, I would suggest trying to solve, trying to make x plus 9 or 2x plus 16 0. And you can do it either way. Either way should bring you the same answer each time. However, I would recommend that you try both ways for your own practice. I'm only going to show one way, but I do recommend you do both ways to see if you get the same answer, because you should be getting the same answer. So first, do k times x plus 9, and we're going to plug in x equals negative 9. So plugging in at x equals negative 9, I show it right here, you should get c is equal to 5. If you go back farther in the video and you watch some previous parts of it, you will see that 5 was the value of where c is right now. So if you check, that is correct. And now that we have c, we can keep on going. Right here. Now you have to try to isolate k. Now, do note, you could also plug in the value you just got for c, because it is the value for c, and then that would make things a bit easier, though it's not necessary. And I feel like if you just followed the same process with k, it would just be easier. So I did the same thing with k here. I plugged in x equals negative 8 to eliminate the term c times 2x plus 16. This would isolate k into an equation. You can see my work further down right there. Next, you can see this is the completed partial fraction, and here you go. You can check it. Do try it the other way, and pause the video if need be. But after this, if you are not here for the pre-calculus, if you are here for only the pre-calculus part, which is just splitting it into partial fractions, there isn't really much of a need to continue. I'm going to do the integration part right now. It's quite short. If you do want to stick around, it would be kind of hard to understand. It's not that important. But if you are taking Calculus PC and you are looking to learn integration by partial fractions, this would be a good review. So I just mentioned that. So here you go. So let's make this function that we just got, f of x, this newly split function, and now we're going to integrate it. How do you plan on doing that? So using the addition rule of integration, if you just take the integral of f of x, you can take it, and there are two multiplied terms, and in this case, sorry, not multiplied, added terms. In this case, we see the two added terms, 5 over x plus 9 and 7 over 2x plus 16. So you take the integral of each of them. You can do that due to the integration rule of addition. And so you can see right here, there's my attempt at drawing an integral sign on Google Slides. So, you can laugh at that in the comments if you want. Once you do that, you can just take the integral of that. And so here I just put in the function right here, 5 over x plus 9, 7 over 2x plus 16. By the way, when I forgot to put the parentheses here, but the parentheses surround the whole, the entire function denoted by the integral. And I do it more specifically here. The integral of 5 over x plus 9 dx plus 7 over 2x plus 16. Now try integrating this. But before you do that, keep in mind, remember the rules for u substitution, and remember the rules for constants, and remember the integral of 1 over x, or x to the power minus 1, whichever one you remember it better as. So just remember those as you are trying the problem, trying to integrate. So once you integrate, you should have gotten something like this. Now that you've gotten that, do remember the plus c, and if you didn't notice, you might be a little confused as to why the coefficient on the second term is not 7, and I put it as 3.5, and that's for a reason. It's because of u substitution. I might make a video on that later, but basically what happens is, since the inner term is 2x plus 16, a 1/2 comes out of the term, and it divides the 7 by 2, and that's why you have 3.5. I'll make a U substitution video if you guys want it. I'll see what reactions I get from this. Again, don't forget the plus c. That's for every indefinite integral whenever you're anti-differentiating. So I also, this is unrelated, but I have a Patreon page that's coming soon. It's not going to be released yet. I recently removed the link from my channel because I'm still working on it. Here's a blurry Patreon image just to represent. Yeah, new Patreon page is coming soon. You can donate through there. I'll have 3 tiers. I'll talk about it more in a different video that I'll release later. And lastly, good luck on the AP Calculus BC exam or your partial fractions test, whatever you're watching this video for. I also, as I said in my physics videos, leave feedback. I really need it. I would love some feedback because I want to know how to make these videos so they're better for you. I currently don't make money off these videos, and Patreon is going to be probably my only source of income for the time being. And so I just want to know how to make these videos for you. I hope you are able to recognize that I'm not on the best of budgets, so I am still in high school. So either way, enough about me. Do leave your feedback for what problems this video has. So thank you for watching, and as always, just stay tuned. Leave a like if you did like the video, subscribe if you want to see more, and goodbye.